disadvantages is you're less likely to be broadcasting audio or have your mic on or feedback or something. That's true. That is definitely a feature. And also, if you happen to be here in person, I have a shiny timer thing. And if the chairs happen to mention how long your presentation slot is, I will try and set that, and so you can know how much time you have left. Yeah. And as you can probably tell, I am neither Fred nor Ron. I am just the monkey who's sitting in the chair, largely to try and keep order in the room. So, if anybody misbehaves at the mic or something, I'm the bouncer for ensuring compliance. You will comply. Let's see. Let's make sure that these mics work. Woohoo!
Warren, are you running the slides as well?
Could you repeat that? I missed it.
This is Fred. Are you running the slides as well?
I believe that the chairs, are doing the slide bits, because I don't know what order things go in. So.
Well, they go in the order they are on the meeting materials site.
Okay, let me see if I can get that logged in. One of the problems is I don't have an easy way for people to change to the next slide because I do not have a clicker thing. So I can't hand people a clicker for if they need to change their slide if they're here in person.
Okay, then they'll have to ask us to go to the next slide. Nice. So I'm looking at the choose deck to chair, and it shows two sets of slides, the first and last. Do I have to share from here then?
I missed the question. Can somebody in the room repeat it? I mean, if the chairs would like, I can do the slide sharing from in the room so that people can say next and I can push the next button. Otherwise, if anybody has a USB-C to USB-A converter, I can plug in a clicker thing. I'm only slightly terrified about plugging a random. Does that have a converter? Yeah. Woo, converter! Great! It's a corporate machine. I'm sure it's safe.
Okay, Warren, I have all of these slides up at the meeting materials site, but for some reason, when I choose a deck to share, it only shows two sets of slides.
I will remind people that this is the first meeting of the IETF, and so the logistics are always a little fun.
Hello? Can you hear me?
Yes.
Hi, Juan Carlos Zúñiga here. I attended a Miteco training yesterday, and there are a couple of features. So first of all, the chairs need to share the slides, so they have to prepare them. Second, for moving the slides, if someone scans the QR code with their phone, they can actually move ahead and back, so that you don't need to get the pointer. They just have to request permission to control the presentation, and then anyone from the phone can actually control the back and forth of the slides, if that's more convenient, so that we don't have to pass around stuff.
And there we go, I'm just waiting for Data Tracker to log me in. And I just closed the wrong tab. Sorry, everybody.
Okay, I'm trying to share from my laptop, and the system doesn't want to do that for some reason. Yeah, the meeting materials is broken.
Here we go. I should be able to do it.
Okay, good. The first set of slides is some administrivia.
Woohoo!
That's the last set of slides.
Yeah.
Let's see.
So the only set of slides that I see is deployment status, and I see 2 decks list in the things, IPv6 deployment and IPv6OPS working group procedures. Those are the only slides that are loaded.
Let's see if I can share from here.
Why don't you?
Pardon? Great.
Okay, can you see my screen?
What I see right now are your slides, Ron.
Okay. No, it's not letting me share either. I'm going back to seeing the video of the room. Warren, do you have control?
So what is the set of slides called that's supposed to be being projected? The only set that I listed is deployment and procedures. If you email them to me or something, or add them to the meeting materials page, they'll show up.
I'm going to send you something from Data Tracker, and it has a link to all the slides.
When you say you're going to send it to me, how?
It will be in the chat room.
In the chat room. Sweet.
In the
chat room. There we go. Waiting for Data Tracker to load. V6OPS. Show meeting materials. So which one do you want first?
Okay, if you open that page and scroll down to slides.
Yep, Administrivia.
Yes.
Okay, now let me just make sure I can share this tab. Luckily, we in no way look unprepared. And I've lost the Meet Echo tab. My God, we're good at this. Can we open tabs? Let's share slides.
Oh.
So I've asked to share screen. If one of the chairs can approve my request to share screen. Ron or Fred, can you approve my request to share my screen?
Yes.
Thank you.
Ah, we're there.
Yay, 10 minutes. Let's just pretend that this is full screen and not deal with trying to make it actually fit, because... Okay.
Well, okay, guess what? You're in V6 operations and we're trying to figure out how to make this work. Next slide. Okay, if you haven't seen a Notewell screen before, you see one now. And this is basically, you should remember the things you say here. You have legal significance, and so, don't be stupid. Next slide.
I clicked it, waiting.
Okay, so I see it now, meeting tips. Please sign in using Meet Echo using the on-site queue and use it to join the mic queue. If you're remote like I am, please don't share unless you're intending to speak. If you're intending to speak, headset probably works well. Next slide. These are some good things to know. And next slide. So this is our agenda today. Question, does anybody have any changes that they would like to make to the agenda? Hearing none, this is the agenda that we'll use. And the first speaker is talking about the deployment process. Gabor, are you around?
Trying to get the next slides up.
Yeah.
Come stand in the pink box, which isn't actually pink or marked. And sadly, you're going to have to say next, and I'm going to have to click next. Does anybody mind if they remove the mask so you can speak at the mic?
Yes, be clear. So, good morning. My name is Paolo Volpato. I'm presenting on behalf of the co-authors you see listed here. And we are talking about the draft on the deployment of IPv6. So, the next slide, please. So, just to give you a bit of the history of the draft, you see that we submitted as the personal version in it was October 2020. In April 2021, it was accepted by the working group as a work group draft. And basically, we completely reviewed the draft for IETF 111. It was a version 02. So we did the kind of major transformation. We introduced a lot of changes. We reshaped the table of content. Let's say since version 02, the draft can be considered as stable enough. After IETF 111, we had 3 other versions, but basically those versions were, let's say, prepared to address the comments raised by you, by the working group. And we are now at the version 0.5. So, by the way, you see there are the list of people who contributed in the discussion, and there are others who also provided comments offline. So next slide, please. Good. So where we are right now. As I said, version 0.2 was, let's say, done to address the comments received for IETF 111. We touched the table of content, but since then it has remained stable enough. And the other changes we did, mainly in version 0.4 and 0.5, were to, let's say, update the numbers about the deployment and the adoption of IPv6, and we touched also the text, for example, addressing comments, asking to introduce new references to avoid the ambiguity of some terms. You see an example there, for example, remove migration to IPv6. Just use the term transition to IPv6, or let's say expand what we considered as the base text. For example, please explain a bit more the behavior of happy eyeball. So those were examples. You see better in the next slides what we have done so far. So next one, please. Yep. So you see the table of content. As I said, it has been stable since version 0.2. Let's say the list of the topics is what you see there. What we touched in version 0.4 and 0.5 is highlighted there. So version 0.4 in light blue and version 0.5 in yellow. And as I said, basically it was to introduce some slight modifications or just touch the base text. More in the next slide. Okay. So basically, I'm not going to give you the full list of details across the table, but just to highlight the main changes. You see version 0.4 was about introducing an update on the numbers of IPv6 adoption and users, whatever. It was in section 2 and 3. And then, as far as version 0.4 is concerned, also we touched also section 5. So we added more references. And section 7.3, we basically reviewed the test about the operations of IPv6. For version 0.5, we introduced changes in section 3.6. So basically it was about, to expand the behavior of API ball. We also touched other sections, for example, section 4, 4.1, 4.2, just to explain better, and thanks for the comment we received, that introducing IPv6 in the overlay is a matter of having, let's say, 2 steps or 2 phases. We named them IPv6 introduction and let's say full transition to IPv6 only. Basically, those phases are not to be considered as a sequence. Clearly, an operator can jump on one of the 2 according to their plans. So clearly, from a deployment perspective, you can have the first phase, but just to be, let's say, the preparation for the second one. An operator can also decide to jump directly to IPv6 only. And if I'm not wrong, yes, then we also corrected some terms in one of the last sections of the paper, so 7.4.1. So basically, that is the situation right now. So if you move to the next slide, please. As I said, the draft received a few comments, but overall, the content, the table of content is stable enough. So we'd like to ask for the work group last call, so the adoption of the draft. In any cases, any comments, any questions are more than welcome. And this is it. Thank you.
Okay, let's throw this open to speakers at the mics.
There's no one at the mics in the room.
Fred, if you agree, I think we can queue this up for working group last call. But
Sounds good to me.
before we do that, we will set up an issue tracker so we can track what goes on in the last call. So the last call should start in 7-10 days, something like that.
Sounds good. So Paolo, I take it you're done. Should we move to the next speaker?
Okay. Thank you.
Okay. So Martin,
Can I proceed? Or?
yeah, go ahead.
So I will be speaking about detection of NAT64 DNS64 through the SRV records. Please, next slide. So why? Next slide, please. There are several solutions right now to solve the issue. There's a RFC 7050. Thank you. This uses the DNS, well-known name, and has been updated by RFC 8880. There's also 7225, which uses a port control protocol. There's also DHCP, V6 option, and array option. Next slide, please. But these solutions do have some issues connected with them. The 7050 is pretty hard to implement right. It's easy to do wrong, and it's easy to use even if it's implemented wrong. But in this case, it's not quite secure. It doesn't work with the DNS providers other than the one of the ISP. It has been updated by 8880 to use only the one DNS from auto configuration, but it can also be modified. 7225 is largely ignored. Same also for the DHCP option, which is ignored by Android because of DHCP. And there's array option, but there's not, I haven't seen implementation in routers so far. And concerning the time in which routers are replaced, then we won't see it for some time in some networks. The later three solutions are not quite usable for user-space application, not typical one, because they usually don't speak either port control protocol, DHCP, or array, and there might be also issues with mandatory access control. Next slide. The RFC 7050 requires to be secure DNS signed records corresponding PTR. These are obvious. And then there's a requirement of secure channel between node and the receiver, which is not always the case. There's also the trusted domain list needed, but there is no written how this list should be populated. And there is only mention that there should be no user input, so user can't actually says that this domain is trusted. Then there are three other requirements from 8880. Subversal must distinguish between auto configuration of DNS because it has to use the auto configuration only. And the recursive DNS resolver is interface specific. These are problematic, at least what I have seen in Linux. The resolve conf doesn't include the source of the configuration of this information. So this RFC 7050, when you had to follow all the requirements, It's quite hard to implement, and one implementation I have seen on Linux, then it just uses the well-known name and asks for well-known name and check the PTR record and nothing more, and it didn't follow all the requirements. Next slide, please. So how do I think this should be approached? Next slide, please. So I've put several goals of which the method should use or follow to be usable. First of all, I think that there should be no protocol alteration or new protocol introduced. It should use only widely supported protocols, like the application already knows how to talk. Utility information already provided, so the node can know what information should know what information the so it can just use the information it already has. Must work with foreign DNS, so no matter what operator the DNS would be used, it should be also work with it. No synthesis on the host, so no other things that are not already introduced into Node. And must work with no prior provisioning. So when user brings his own device, there should be no exchange of certificates and so on. And must provide detection over insecure channel and must run in the user space. So every application in the host can utilize this method. Next slide, please. Okay, what are the results? In the draft, there is a the SRV records are there established. The application should the application already knows how to talk to DNS, or at least every application should be able to. A nodes is IP address, so it can have a PTR record. The information must be presented in a global DNS tree, so every DNS provider can serve this information. DNSSEC should be used to provide authenticity. So I think the SRV records are good place to place such information because they are structured, they do have priorities, weights, and they do have a time to live, so they can be updated periodically. And it can be up to host specific level. So for every PTR, there could be different SRV record and different NAT64 gateway. Next slide, please. So how the SRV record should look like, at least from my perspective. There are two proposed SRV records, one for NAT64 and one for DNS64. It can be for the host fully qualified domain name or the domain itself. It utilizes the priorities and weights. Only the port number can be utilized to transmit other information, but it's not mandatory to use it this way. The SRV record would then point to a Quat-A record, which would contain the information about the prefix used. Also, there could be also DNS64 record to transfer information about DNS64 service. Next slide, please. So what are the news from the previous version of draft? Next slide, please. So there is version 01. There has been just detailed some process of the local domain detection from the PTR records. There's also updates from the previously wrongly submitted draft on IP 104, and there are some changes in version 00. It uses a PTR record instead of DNS search list. It's because the DNS search list is not transitive throughout the routers, and this information, the PTR records are. Because of this, the node which knows its IP address can utilize the PTR record, and with the dynamic PTR record, it's possible to transmit a local domain to the node. There are also specified now some interaction with other methods and for SysForXLAT. There's also mentioned that any transport method can be used, so not just a plain DNS, DOH, DOT, anything actually. There's also specified how the negative answer should be counted, and what the node should do with the time to live. There's also mentioned that there can be also the multicast support, and there's a proof of concept code on a GitHub repository connected with the draft. And so the last changes are spelling and grammar. So next slide, please. This should be the last one. So thank you for your attention, and here's the GitHub repository with the proof of concept code. But be aware that I'm not programmer, so the code, I'm not saying the code is safe to use.
And while people are working up to the mic, there is chatter in the IESG room that people do have to wear masks, including presenters and Benno's and Michael's. Sorry. Jen's on the line, so okay. People can see the queue. I'll let the chairs do stuff.
So Jordy,
I have some questions about the document and the presentation. Just clarifications. I am not opposing to the document at all. Just making sure that some things are correct. The first one is that RFC 7225 is actually being used by some ISPs, so it should not be ignored. I am not sure that RFC 8115 can be used for NAT64. I've never seen that. I never tried it myself. The other question is that most of the CPEs that I see and even operating systems like iOS or Android, when they are ready for using NAT64 or 464XLAT, they have already pre-configured the well-known prefix, okay? The other point I have is DNS64 synthesis is actually a good thing for being done in the host. So I am not sure how we should recommend not doing that, if that's the intention of the document, or it was a confusion in your presentation. There is, yeah.
No, I'm not recommending to not to do the DNS64 synthesis on the host, but I think the method should allow those hosts which don't do the synthesis to also work with this method.
Okay, clear then. There is another problem is that you mentioned about some operators that the host know the PTR, his address because the PTR. This is not actually true in many cases because some operators do not configure PTRs for enterprises. I mean enterprise connections, even unless it's specifically required, and even less for residential users. I know this is not good, but it's the reality. And my last point is that considering that most of the deployments are using well-known prefix, maybe we need a document that describes practical use cases for the network-specific prefix, or otherwise, do we really need more procedures to learn the NAT64? I am not really convinced that therefore makes sense. Again, I am not against the document, but I am not really convinced that it will make sense. Thank you.
So just I will react on the PTR record. I know that it's not the usual thing to make the PTR record, but there are implementations that allow dynamically generating those records. So it's possible to use. I've also tried to configure it myself. It's not really a problem to do, but I also understand that it's not the typical use.
Thank you.
Yeah.
Ralph, are you standing at the mic?
Okay, so you say PTR is the entry point into the secure delegation, yet in the draft, I might have read the wrong version, there's no example of the PTR. And what are you going to do with, people in non-public IP space? So how are you defining how to get the actual public IP space? Because you might be RFC 1980 or EULA or what have you, that is not routable. So how are you going to get the IP? And
sorry, I don't really understand the question.
so in ADD we sort of had a similar problem with upgrading DNS servers, and we decided against the PTR because it was hard, what Jordi said, to get delegations in PTR, and also you might not have public routable PTR available. So you're saying that you have to have public routable PTR available for that to work?
Yeah, you can use so-called dynamic PTR records. If you do have it on your authoritative DNS server. For example, the Node DNS does have this module that generates those PTR records and sign them online with the DNS sec.
Okay, and when you say from the PTR, again, there was not an example, you get a domain, but that domain is not what you're looking for into the SRV record. You are walking it kind of label by label to get something that is working. Is that correct understanding?
I don't.
So if your PTR record points to myhost.example.com,
yeah.
then myhostexample.com might not have the SRV record.
Yeah.
The SRV record might be at example.com.
Yeah. So
you're
first ask
labels.
for the host-specific SRV record. So for a full qualified domain name, and then if there is no record, not even a dot record SRV, then you moved one step up.
You remove one label, right?
Yeah.
And the draft says you are stopping by the second level domain.
Yeah.
Now there are third level domains that are kind of actually second level domain, like co.uk. So the draft should maybe define more where to stop, because otherwise you could have a rogue actor doing something bad to that.
Yeah, this would be, if you use such method, then it would be good to place at least the dot record of the SRV, so the process would stop before reaching this upper domain.
Okay, thanks.
Ted Lemon, Apple. First of all, the document seems to be using the PTR record to discover the local domain, but as Ralph was saying, it doesn't actually say how that's done. Are you aware of RFC 6763, the DNS service discovery?
Not from the top of my head right now.
Okay. It would be worth reading that, because RFC 6763 actually specifies how to discover services using the IP address to look up a PTR record. And I think, just referencing the mechanism that it uses, and in fact, you could probably just use DNS service discovery directly, because it's doing almost exactly what you describe in the document.
Okay.
The other issue that I would concur with the point that was raised earlier, that doing validation in the stub is better, and so therefore synthesis should also happen in the stub. Sorry, my brain's a little foggy from being up too early. So the security properties that you talk about in the document, you haven't actually justified the existence of those security properties, and as far as I can tell, there aren't any. the document doesn't actually provide any additional security. So it would probably be worth taking that out if you aren't able to explicitly say what security is provided. And if you want to say what security is provided, you should describe explicitly what security you're providing, because as far as I can tell from reading the document, this is no more secure than any of the other solutions. I mean, if you bootstrap based on a non-secure DNS lookup, for example, essentially you're just trusting the network. So it's no more secure than DHCP.
Yeah, you actually, when you do have a secure delegation of a PTR, and you do have, and you're supposed to have the address of the node valid and right. Provided by some secure way, at least RA guard or something like this, then you can go from that and use the DNSSEC route to actually validate the information every step of the detection.
I understand that, but the problem with that is that assumes that you have a secure delegation for the PTR record, and for almost every IP address that any actual node is going to get, you can't establish a secure delegation because it's going to be an RFC 1918 address. So for the vast majority of use cases, you don't get any security. Now, you could, for example, talk about a CE router that does validation of the RFC 1918, sorry, of the PTR record, because that PTR record could have a secure delegation because it's a public IP address assigned by the ISP.
Yeah.
We hope, but in the general case, you can't make that assumption. And yeah, okay. So if you have an IPv6 address on the network, then yeah, you can have a secure delegation for that. So that's sort of useful. It would also be useful to connect that to the RPKI validation. But in any case, the point is, if you want to have that, if you want to make security claims, you really need to document them.
Okay, so I should write there should be a secure delegation from the address to the PTR zone and then also forward zone.
Sorry about the RFC 1918 comment. My head was a little screwed up. That obviously wouldn't be relevant.
Jan Linkova. First of all, I'm a bit confused about the differentiation between application and a node. You started your draft with an application might not have access to array information. And then your draft continues saying, oh, this method should be used before any other method as soon as address is configured. So, and it keeps talking about a node, which I read as an operating system, right? So are you suggesting that the host should ignore information received in array until this process, which means sending a number of DNS packets, is completed, and only then you can start using array information, which, to be honest, looks a bit confusing to me, because you introduced a lot of delay in configuring a host. And by the way, some routing vendor are implementing array option. It will be released, like, I think, next year. So you will see it in the routing vendor configuration.
Yeah, I hope that that we will see this array option implemented soon. But what I can see from the operators I'm working for, they will not change the routers in few years. So between the array option would be introduced into firmwares of the routers. Not every router would have a firmware update, and not every router would be able to produce this array option. That's why I just included this in the presentation. That I haven't seen it so far. But I like actually the array option for detection. But in some cases, when, for example, on Linux, I can't see in the CRD implementation that it would be able to access the array option. That's why I'm proposing to do it through the DNS, because every application inside the host can access the DNS through the stub resolver.
Okay, so in this case, the text is even more confusing, because if your system or node, whatever you called in the draft, could not even access array option, how can you recommend using this method? And then, based on preference number, wait for another method to complete. If you're claiming you can't even access array option.
If you can't use other methods, then you have to stick with the methods you can access.
So basically, I think the draft is very confusing about how it's supposed to work between application and the operating system, especially when draft is saying doing something if you don't have CLOD or doing something when address is configured. Your application might not even have access to that information, right, at all. And by the way, you're saying when an IP address is configured, are you expecting that system will be doing for every IPv6 address configured? Because it might have many.
Yeah, it might. If it comes from the same prefix, there's no point to actually ask for every single IP. But yes, it should generally ask for every IP.
And I think the last comment, I think it might worth clarifying what to do if there is IPv4 address present, because I don't think the draft even mentions that.
Yeah,
you don't even know when you're supposed to use this mechanism.
Okay, I'll try to write it into the next version. Thank you.
Tolles Eckert. So if I understand you correctly, the goal is to make it easy for applications using a simple library on top of supposedly existing DNS libraries to utilize the scheme. So let me not comment more on the feasibility of the specific choices you made, but given how the long list of not seemingly easily adoptable options we've already built, it seems to me that the one thing missing would be to also have an abstract API specification about how applications should discover and utilize the 6.4 mapping information, so that well, we don't necessarily have to get hundreds of applications trying to read that draft and trying to do their own implementation, and also us ending up getting a lot more freedom when we're basically saying that the ultimate specification against which applications are written is not all the details of any specific DNS encoding, but that can be changed and enhanced over time without necessarily changing the API, right? But just being able to, in an agile fashion, improve on the libraries, keeping the APIs, and then if these DNS things are not secure enough or need to be improved, then hopefully we could do that a lot better, right? So just don't think about the protocol elements that you want to do with DNS, but also think about what is the abstract API. Maybe go to tabs with that. I'm not sure if they're more experienced in something like this than V6OPS would be, but certainly I think it would help a lot to move this forward if there was also that API aspect covered.
Okay, thank you. I'm going to have to ask any further comments. We're going to have a discussion on the list. Let's take this off the list. And speakers in general, I've asked you to confine yourselves to 10 or 15 minutes. We are now 48 minutes into the first hour. It's really quite a bit. I believe we need to move to the next presentation.
Thank you.
So, okay. So, Gabor, I believe it's your turn.
Hello, can you hear me? I hope that everybody can hear me.
So maybe Gabor can actually share his slides directly, so that might work better. Is that the plan?
It's good for me if you share my slides. I can share my own laptop. Maybe, yeah, maybe let me with your slides. Okay, let me go back here. Okay, so I can see the slides. and I hope that you can hear me. So my draft is about some measurement results about the scalability of IP version 6 transition technologies for IP version 4 as service. Could you go to the next slide, please? Thank you. So in the last version, I had some, let's say, warm-up results about IP tables, but now they are real IP version 6 transition technology results. So it's results of Joule, stateful N86 implementation. It was recommended at the last IETF meeting, and it is an open source N86 implementation. And as last time, I again did two kind of tests. Scalability agents, the number of CPU cores, and scalability agents, the number of concurrent sessions. So the method is described in our draft, which was presented already twice at BMWG working group, and the session chair liked it. So the problem is that if you use, let's say, stateful N86 you cannot send traffic from the version 4 to version 6 direction, just the random port numbers as would be required by RFC 4814. But first, you need to send traffic from the version 6 to version 4 direction. You must observe the IP address and port number combinations, and you should reuse some valid port outputs. Could you go to the next slide, please? Thank you. So the scalability agent's number of CPU cores were done with 1, 2, 4, 8, and 16 CPU cores, and we measured the maximum connection establishment rate, which is a new thing for stateful technologies, and the throughput, which is the normal throughput recommended by, let's say, RFC 25.4, but of course, we use the methodology of RFC 82.19 for IP version 6 technology. And here is the description of the hardware used for the test. You can jump it over and go to the results for the next slide, please. Thank you. So here are the results. Unfortunately, you cannot see my mouse pointing, but in the first row, you can see the number of CPU cores, and the second, third, and fourth line, you can see the median, minimum, maximum values of connection establishment rate. So as you can see, from 1 to 2 cores, it is increased, let's say, for 220 to 350 kilo connections per second. So it's quite okay, not linear, but quite okay. And even with 4 cores, it's significantly higher. So it's not linear, but quite okay. However, for 8 on 16 cores, it doesn't scale up well. So unlike last time, I showed the results of IP tables, which showed about more than 10 times performance at 16 cores compared to single core. Now it's about less than, let's say, 4 cores with 16 cores. So it's really bad scale up. And also you can see throughput is very similar. It scales up somewhat to 4 cores, but after that, it doesn't scale up well. Will you go to the next slide, please? Thank you. And the scalability agent is the number of concurrent sessions. It means that if you increase the number of sessions, how it will behave. So I increased the port number range, both the source ports and destination port number range was usually doubled. And this time I couldn't do any tuning like with IP last time. So I measured 3 kind of quantities: maximum connection establishment rate and throughput. And there was some new, which is the connection tear down rate, which has been defined lately. And on Wednesday, I will talk about this methodology, but I will shortly mention this one too. So could you go to the results? Next slide. Thank you. So here you can see that in the, just that, okay, thank you. So on the first line, you can see the number of connections starting from 1.5 million, and then 6 million, and 25 million, and 100 million, 400 million, and up to 1.6 billion. So you see the number of source ports were always doubled, except the last case when I couldn't double the source port, but increased 4 times the destination port. And you can see here the connections per second median and the throughput median values. You can see that there is some degradation, not so bad, but there is some degradation. So with the number of connections, the performance somehow degraded, concerning both connections per second and throughput values. Could you go to the next slide, please? Just something new. The connection teardown rate. Unfortunately, we have now better method than an aggregate measurement that we load a given number of connections into the connection tracking table using the first phase of the test and then delete the entire connection tracking table. And of course, we perform the measurements with different kind of number of states or connections in the connection tracking table. So I did some further refinement that I also subtracted the deletion time empty table. Could you go to the next slide, please? Thank you. So here you can see the results. The first 3 lines are the same as before. So you can see that, yes, thank you. So you can see that we use the same number of connections, and you can see that the deletion time of the full table in number row number 4 was increasing. It's about 4 times increased. And if I subtracted the deletion time of the empty table, then which was always 0.46 second, it made some better results. And you can see that the connection deletion rate is nearly constant with any number of connections in the connection table. Could you go to the next slide, please? Thank you. So these IP tables, I retroactively performed the connection teardown rate measurement with IP tables, and it was funny that IP tables produced a very high throughput and also very high connection establishment rate. It was in the order of millions per second, and its connection teardown rate is quite low, so it's just in the order of 400 or 300 kilo connections per second, so it's really, really low. Please go to the last slide. Thank you. So I have a few questions. If you like the idea of how I measure the connection teardown rate, and just more general questions, if you feel that these measurements are satisfactory for you, and if these results are interesting for the operators, and potentially if this draft could be adopted. Thank you.
Okay, thank you. It looks like we'll need to take comments with the list, and again, you know, this will all be discussed. You know, we'll have the weekly discussion periods, and part of that, of course, will be if you feel that we should adopt the draft, then you need to say so. Okay, so Mr. Shu, I believe you're next. And pardon me if I mispronounced your name.
Yes, good morning, everybody. I'm going to talk about the ND deployment GIF. Next slide, please. So first, I'd like to remind everybody what this GIF is about. So ND, neighbor discovery, rely on multicast extensively. ND also trusts other hosts. So depending on the L2 media, for example, if it's on a wireless media, if you use multicast, you may consume a lot of energy, and also multicast may not be as reliable. The other issue is that if you trust other hosts, I think that in an enterprise environment may be okay, but in a public access environment, there may be issues. So as a result, over the time, there are more than 20 RFCs documenting the various ND issues and the solutions. So first of all, it's not easy to understand all the issues and solutions. So in our draft, we summarize all these issues and solutions into a single place. So it makes it much easier to reference because ND is a very important protocol, it's a critical part of the first hop. So this makes things a little easier. And another thing is that we clearly clarify that host isolation, meaning that putting all the hosts, isolated from others, is very effective in preventing some of the ND issues. We also provide a guideline, say where to isolate hosts and where not to isolate hosts. For example, if you need, multicast DNS, then you don't want to isolate the host because that will break the service isolation. And the overall result is that we believe that this will, when you apply in these guidelines, it can simplify the first hop deployment. Next slide, please. So I would like to talk about one of the key contributions of this draft is that, as we said, if multicast or, you cannot trust other hosts, then, if you isolate the host, then obviously if there's only a single host, then the multicast issue will go away. You don't have the trust issue of other hosts because other hosts are separated into, different subnets. So this idea first came from RFC 8273, and it's called unique prefix per host. But when 8273 was, before it's published as an RFC, there's actually a long debate in whether, it's a good idea to publish it as an RFC. And some of the concerns expressed, including, well, there are certain corner cases because RFC 8273 it basically proposed this subnet isolation, and it automatically assumed that the hosts are also isolated in L2. But there are certain corner cases. For example, if you have a multimedia access, this may not be true. So there are certain corner cases, and also there are some opposition that, if you do this approach, then the router becomes stateful, and some other use too many prefixes because you're basically giving each host a prefix. So in our draft, we explicitly propose that we combine the subnet isolation, which is this unique prefix per host, also with L2 isolation, to make sure that in layer 2 they are really also isolated. And when you kind of like constrain the application scenario of RFC 8273, then you avoid the corner cases. This is the first one. Regarding the stateful router, we believe that it's a good price to pay because when you do this isolation, then the host, you don't need to put the mechanism in the host to avoid this problem. For example, alternatively, the wind, the wireless ND RFC 6775, they propose some changes to the host, which we believe that is more complicated. So we believe that this, by constraining RFC 8273, we believe that this is a good trade-off. In terms of requiring too many prefixes, we believe that it's not a problem because nowadays, most operators can get a /29 almost without justification. Everybody can get a /29. Slash 29 contains, 32 billion slash 64. So it's more than enough. Really, the scenario where we have the most number of hosts, for example, in mobile broadband, we are already giving, each host, meaning the mobile phone, a slash 64 anyway. So really, this is, we believe that use too many prefix is not an issue. Actually, this take advantage of the plenty of address of IPv6 to simplify the deployment. So we explicitly discuss that this is idea, this host isolation, where it's good to be applied. We identify that, if it's a public access network, so, you may not be able to trust other hosts, then, host isolation is a good idea. Or in a wireless, especially low power environment, where, multicast can consume a lot of power unnecessarily, and also, may not be that reliable. So in this kind of scenario, it can be, a good idea to apply this host isolation. But again, if you need a multicast DNS or your environment is very safe and it's wired, you don't have the issue we talked about, then you don't need to apply this host isolation. So we believe that, this is actually some useful consideration for the deployer. Next slide, please. So in this last slide, we basically summarize some of the change from the previous IETF. So last time, Dave Taylor and Eric Klein, they read some comments. I think the first comment is about the multi-link subnet. So in this version, we add a paragraph to address the concern of this multi-link subnet. And then the other change is that last time, Yan Linkova talk about, well, if you do host isolation, you may use many more interfaces, which is true. So, in this version, we add, we address these, the impact of many interfaces. But generally speaking, this is in a public access wireless environment. We believe that, the routers today can generally support this number of interfaces. So it shouldn't be too big a problem either, and then some minor English problem. So again, we believe that this is a useful document for the community to consider, and that's my presentation.
A couple of minutes for comments at the mic.
Hi, Jared Mach. Normally I would say Akamai, but in this case I'm going to put on I actually own a fiber to the home ISP. So in this case, I've just started to enable V6 for my end subscribers. In this deployment case, would I now need to allocate a lot more V6 space to them because in their home network, they would need to allocate a /64 per device?
From our perspective, I think that a /64 is already enough. But we certainly know that there are some operators allocate, for example, 56 or even 48. I think that my short answer to your question is no. From our driver's perspective, all we care is that each host get its own prefix. These prefix can be 64, can be can be longer or shorter. From our driver's perspective, we don't really care. I think that you probably care. I think that the how long or how short the prefix should be. I think it depends on your own.
Yeah, I mean, I'm specifically thinking about the embedded devices where the user doesn't have a lot of interaction with them. So you take something like a printer and a phone, which might suddenly find themselves on a different IP subnet from each other, and the end user is not going to be able to print anymore potentially. Which is that's the type of thing that in some cases that they actually phone the ISP for.
Yeah, you are right. So we believe that in a home network,
So yeah, I mean, this definitely concerns me here if this is something that we were to move forward with.
No, let me clarify. We are saying that, you give each home a prefix. I think that in this case, when we say the host, we actually mean the CPE. We say that, you give this CPE and put different CPE on different prefix. But what we are not saying is that inside your host, you also put each computer into a different subnet. Again, what we are proposing here is that this host isolation, it has a certain scenario it's suitable for, and it has a certain scenario it's not suitable for. So if you are talking about the host inside your home, we clearly say in our draft that, this is not a scenario that you will apply this.
Okay, I guess on the next one, Eric Vink.
Yeah, please. Go ahead.
So indeed, this solution fixes a couple of problems. I just wonder, if I understood correctly, how duplicate address detection works in this case, because two nodes doesn't see each other anymore.
Eric, sorry, can you repeat your question again?
So in this situation where two nodes are no more layer 2 adjacent, do not see each other,
right,
how can node A make a duplicate address detection at that for the address that may be used by another node in the same layer 2?
Well, okay, so if I understand your question correctly, you are asking, well, there are two hosts. They are already separated in different subnet and also separated in different L2. And if they have duplicate address, is it okay? Our answer is it's okay. Because it's not only in different subnet, it's also in different links. So, if their address is duplicated, it's okay.
Okay, thank you.
Thank you.
Hey, Lorenzo Coliti, what do you mean there, if their address is duplicated, it's okay? If a packet comes from the internet, which one of the two gets it?
No ECMP, definitely no ECMP.
Okay, it works half the time. Cool.
The router maintains the state information. So we are talking about, Lorenzo, we are talking about link local address can be duplicated.
Okay. No, we're talking about link local. Oh, so then, okay, then
so they can't talk to each other.
Exactly.
Okay. Yeah. The question. Okay, so question about one thing about per address state on the router. I think mostly with regard to wind, right? So the draft states that wind basically allows solves most of the problems because there's no attacks that can be mounted. But I think you should note that the hosts themselves can DOS the infrastructure by applying for many IP addresses, right? So that's one thing, right? If I'm a host and I create 1 million IP addresses, that's pretty easy for me. Then the router will fall over and it run out of ND cache space, right? And because a host has to register the address, right? So that's something where the host can attack the infrastructure, which is not possible in 8273. It's not possible in prefix per host because the router can just throw away all those entries. It doesn't care, right? It just needs one MAC address for the 64 and that's it. So in a situation where you don't trust the hosts, you really want 8273. You don't want anything else.
I don't fully understand you because in this draft we're actually kind of like making it even more stricter than 8273. So if 8273, if you can accept that, then it's definitely in our we will not have.
It's stricter because the router has to keep more state. In 8273, the router has to keep a 64, right? But but if you do wind, it has to keep the 128s.
No.
No?
No. here, from the router's perspective, the router's state is the same as 8273. The only difference is that, in your configuration, you make sure that, you, for example, using either private VLAN or something, you make sure that the hosts are not only on different, with different prefix, but also, isolated in L2. Okay. So the router doesn't.
But because the draft mentions that the host has to register the IP address with the router. That's what it says in the draft.
Register. No, yeah. only register the prefix, not the individual, not the IID part.
Don't have it, but I just read it. Okay, if the host doesn't need to register its IP address with the router, that's fine then. Right. I don't have an objection. I'll go back. I think I read it.
You double check. Okay, thank you, Lorenzo.
So we'll have more comments on the list in a few weeks. Eric, I believe it's, or I'm sorry, Mr. Shi, I believe it's your turn.
Alrighty, and we're gonna try doing the share this time using Meet Echo. Lorenzo is running back.
Wind, every host must register its address at the router before using it. That's what the draft says.
And please speak into the mic if you reply.
Okay, I'll check with you offline because again, from my perspective, the host only register, so maybe the text is not clear, and we will clarify.
Alrighty, I'm gonna try using the Echo slide sharing. So if the chairs can grant me slide sharing privileges. I think so. V6 deployment.
While we're doing that, could I remind everyone to speak into the microphone and not to the person you're speaking to?
Okay, Mr. Shi, are you?
Yes, I'm here.
There?
Right. Warren, can you share my screen, my slides?
So in the slide sharing, it still only shows 2 of them. But the chairs can once again click the Allow Warren to Share Slides button. All I can see is 2 slide decks in this view which are able to be shared, so I will have to share my screen again. Clearly there are still some bits which require Chrome tab, share, go back, V6OPS. I'm not brave enough to click present because I think that goes full screen and breaks sharing. So,
okay.
Is this the correct slide deck?
Yes.
So. Alrighty. You're going to have to let me know when you want me to change slides, and there is a few second delay.
Thank you. Hello, everyone. Thank you for giving me this opportunity to talk about the requirements to multi-domain IPv6 on the network. This is the first time to present it in V6OPS. Next slide, please. Yeah, first I take some basic viewpoints about IPv6 only. Firstly, IPv6 only is the ultimate stage of IPv6 development. Secondly, IPv4 as service should be considered seriously for this deployment to ensure the service continuity of to access the global IPv4 internet. Thirdly, the deployment is ready to IPv6 traffic ratio When IPv6 usage increases to a certain limit, it would be better to consider IPv6 only. Next slide, please. Yes, during the last 20 years, a series of IPv6 only techniques has been designed in IETF, such as 464 Accelerate, MAP-E, MAP-T, BSNITE, network for V6 for the software mesh network for backbone, etc. Some has been widely used, some are not. Okay, next slide, please. Multi-domain network means refer to network which is composed of multiple autonomous systems. That is AS. Different AS may serve different scenarios, such as metro network, backbone network, 4G network, or 4G or 5G mobile core, cloud data center network. And for the same operator, different AS most likely are often managed by different departments or institutions and using different routing and security policies. So the question here is why we talk about IPv6 only for multi-domain network. Actually, we have some issues when planning IPv6 only in large-scale network, although there are many IPv6 only techniques available. Next slide, please. I will give an example to show the problem. The first one is partial IPv6 only. I will use 464 to illustrate the problem, but I do not mean that it is not a good solution. On the contrary, I think it is very successful, for it has been adopted by several operators. For network, which is composed of mobile core AS and backbone AS, a general model for IPv6 only is to use 464 Accelerate in the mobile core, and the PNAT gateway is deployed as the egress of the mobile core. With this model, the whole network is partial IPv6 only. The mobile is IPv6 only, but the backbone is dual stack. So when the packet from UE go out of the mobile core, it will be transformed back to IPv4 packets. This is not interesting. Next slide, please. So in order to extend IPv6 only to cover backbone network, another option is to deploy PNAT at the edge of the backbone network. With this model, the IPv6 pass from UE to egress of the backbone. But the problem is unnecessary traffic winding. All the traffic to IPv4 networks will go through PNAT gateway and will go the long way round. The data path likely becomes less optimal compared with native routing. Moreover, session level states of users, PNAT is backbone. Next slide, please. Another possible approach is to deploy 464 Accelerate in mobile core and deploy other IPv6 only techniques such as IPv4 over IPv6 tunneling in the backbone network. We all know that IPv4 over IPv6 tunneling is defined in RFC 5565, where the network core is IPv6 only IPv4 client networks. The result of this model is that multiple IPv6 only elements interconnected by dual stack BGP peers. We can find that one domain uses translation, the other uses encapsulation. So the data format in different domains are incompatible with each other. So in this case, IPv4 embedded IPv6 packets need to be transformed back to IPv4 packets at the egress of the mobile core as a PNAT, and then transform to IPv6 in the next domain. And the number of conversion gateways will increase along with the number of AS. For instance, we can see that there are 3 IPv4 IPv6 conversion gateways. Obviously, too much IPv4 IPv6 gateways lead to complexity of the network and the kpax increasing. Therefore, IPv6 only should span the network, and IPv6 should be end-to-end. There is urgent need for multi-domain IPv6-only solution to eliminate unnecessary conversion functions and improve the data forwarding efficiency. Next slide, please. Yeah, here's a general procedure. When ingress key receives IPv4 packet from client-facing interface destined to a remote IPv4 network, the ingress key must transform the IPv6 packet into IPv4 packet into IPv6 packet and forward the packet to the best egress PE. Another case is that IPv4 packet may be transformed into IPv6 packet in UE, as done by 464 Ethernet before they reach the edge of the network. In this case, the ingress PE receive IPv6 packet will look up the packet destination address and forward the packet to the egress PE. So there are two models here. Next slide, please. Next slide, please.
Number 10 or number 9?
So, okay, thank you. So multi-domain IPv6-only network should meet the following scenarios. IPv6 user to IPv4 servers hosted in cloud data centers, IPv4 user to IPv4 servers, IPv6 user to IPv6 servers, and DC to data center communications. We also provide service for transit for local networks, and IPv6 only eBGP at peering in Internet Exchange Point, and the 5G transport service, SD-WAN, etc. Various scenarios should be considered. Next slide, please. Based on our experience, the following requirements should be met by multi-domain IPv6-only network. The first one is that it should be beneficial to wider IPv6 adoption. It should largely reduce public IPv4 public address consumption and accelerate the deployment of IPv6. The second one is IPv4 services. It should provide IPv6 service delivery, and there should be no perceived degradation of customer experience when accessing the remaining IPv4 services. The third one is end-to-end. For any given IPv4 traffic flow, there should be no IPv6 conversion point in the middle of the IPv6 data path when traversing multiple domain IPv6 network. In other words, IPv4 packet should not appear in the middle of the IPv6 data path. The end-to-end requirements also be valid for cloud communication. The next one is that the simultaneous support of translation and encapsulation. The call nodes do not distinguish between translated-based IPv6 packet or encapsulation-based IPv6 packet. At the egress, the PE can recover IPv4 packet by reading the next header field of the packet. So the translation and encapsulation mode in IPv6 only have the same IPv4 IPv6 address mapping algorithm. The fifth requirement is controller dependent. We all know that controller has been deployed by some operators to provide SD-like functions. In the case of IPv6 only, in order to forward IPv4 packet to the right egress point, IPv4 reachability information must be exchanged between the IPv4 network over IPv6. But this process should not rely on the deployment of any synchronized controller. Requirement 6 is user feelings at the border gateway. All that the state will consume great computation power. So it's generally stored or managed at the edge and close to user side. It is unsuitable to store user-related status at the interconnection border gateways with other networks. It should be unaware of the user-related information. The next requirement is high scalability. And it should achieve scalability, simplicity, and high availability. And when PE precise IPv4 features at the edge of the network, the quality of the IPv4 related data should not increase linearly or exponentially along with the quality of user traffic. It is better to adopt algorithm-based mapping approach to avoid excessive data storage at the edge. It should not overload the existing IPv6 routing table. Requirement 8, the SRVs is applicable. SRVs can be supported by inserting SRH in translated IPv6 packet or encapsulated packet. So the network programming can be realized for IPv4 traffic flows. The last one is incremental deployment. It should deploy in incremental fashion, and the overall transition process should be stable and operational. Next slide, please. So this is a draft about the requirements. It does not intend to design any new transition mechanisms. Compared with 2 years ago, the situation of the networks has changed a lot, especially due to the rapid development of 5G and cloud computing. So we should examine IPv6 from new perspective. For this draft, more work needs to be done. We are looking forward to receive more comments and suggestions. We also hope it can be adopted in the future. This is thank you.
Question for you. Are you planning, in one of your slides you mentioned that you need a framework for how to handle multi-domain IPv6 deployment. Are you planning to propose such a framework?
Yes, well, so actually we want to hear the feedback from V6OPS first, then based on the feedback comments, and then we maybe consider to provide a framework or something like that.
It would be good to see a proposed framework.
Sorry?
It would be good to see a proposed framework.
Okay, okay. So from the standpoint of our operator from China Telecom, we hope there should be a framework to give the guideline of IPv6 only deployment in large-scale network. Actually, we have done some trial, some field trial during the last 1 year. We hope to share the result in some cases future.
So this is between you and Internet.
Well, do we have anyone in the queue?
We don't have. We don't have. There's Eric.
Eric? Oh, okay. Okay, I'm sorry. That's the next presentation. So going back to the last presentation, why don't we queue this up for a week's discussion? I'll make sure that the issues are tracked in the tracker. And during that time, we'll ask the author if he wants this to be a call for adoption. Does that sound good? Can you hear me, Fred?
Yes, I can hear you. I thought I said that worked for me. But...
Oh, okay. Okay, Eric.
Okay, thank you. So it's about a presentation about a measurement about IPv6 extension headers over the internet. And the first things I hope that you like the acronym that we used, James, kind of a fun one, at least. So my name is Eric Vink. I am supervising basically students in the Master of Computer Science, which is Raphael. And another supervisor guy is Justin, which is a PhD student also at the University of Liège. So next slide, if you don't mind. So thanks to Jen, Fernando, and Tim, right? There is this RFC 7872. They did something similar but it's 6 years ago, which means centuries ago when we see the deployment of IPv6. So we need to do something else, and we did it as well, not only more recently, right, it's basically a couple of weeks ago, but also using a different kind of methodology, right? We don't use the same system. And no need to say in this room that the survivability of extension headers over the internet is important. If you look about the 6-man working group, and we've got Ole in the room, we know that many drafts are talking about hop biop. And it's not only hop biop. There are other extension headers, as well as new IP protocols that has been recently defined. Next. How we do it, we are renting about a dozen of VMs worldwide, and we send traffic among all of them to make a full mesh. You see, obviously in the map, they are glaring black spots. We were unable to find a VM provider in Africa which is IPv6 enabled. We try as well to get one in China, but it was a little bit more complex. But this one we get good hope. Else, we've got Buenos Aires. Thank you, Fernando, if you are listening to me. We got one in Slovenia. Thank you, Jan. And one in the Netherlands. Thank you, Stefan. Thank you, Sander, on this one. And we got also Bangalore and others. Next. So how we do? It's not only about sending packets and receiving whether and checking whether we are receiving it. We are also sending them like a trace route with a different hop by hop to see where the drop happens. Okay? And we do it in both directions. And it's from vantage point to vantage point. We do not rely on a reply from the destination. We simply run TCP dump on the other side to see whether the packet has come through. Okay? And we basically use SCAPI to send them. This is all the tests we are doing. We are always including a UDP and TCP payload, so the packets looks normal. Using hop by hop and destination option with different size of the option inside the destination header. Right? We should have tried every number, but basically use all powers of 2. We also use all the routing header types from the 0, which has been obsoleted, up to 6, just to please Ron, right, on this one. I mean, anyway, we want to check it. So fragmentation, both atomic fragments, so when there is only one fragment in the fragments, I would say, and non-atomic, so where we have the first fragment offset zeros, but with the more bits on. We use as well authentication header. Mark Smith says, hey, we should try as well ESP. That's for the next one. And then 2 kind of new IP protocols, right? The no next header, which is defined in 8200, and one which is defined in network programming, which is the Ethernet payload. And we just want to check whether they're going through. All those packets always has a payload. In this payload, I am using, or the students is actually encoding the mechanism used in specified in the draft that I have in OPSEC on this one, which is basically inserting either in the DNS or in the payload a pointer to a document describing the experiment, right? In multiple languages required. And then the weak part is that we try to assign the drop responsibility to some specific AS. Not always easy. Things about IXP, things about PE to PE link. Of course, they use the address of one of the AS and not each of one, right? So that's not always easy. Okay, next one. So we send multiple of probes, multiple times, different hop limits, basically to be sure that we try to get really, really the right one. Next. But the most important is not so much about which AS is dropping, it's more about the result themselves. So the only case where hop by hop was behaving like specified is when we were using an unknown option with the bit discard if you don't know it. Because in this case, 100% of the packets were discarded, which is expected behavior. The other one, a few of them were going through. Destination option. This one is more interesting. If we use a destination option, which is only 8 bytes long, it's basically go through in all the 13 meshed thing, they were always traversing the internet without any drops, which is good. As soon as you go to 16, that's still good. You move to 32, you only 93% of the packets are going through. And so on, it's getting worse and worse. If you do the math, 40 bytes of IPv6 header plus 16, 56. This is less than 64. If you do it 40 plus 32, the first one we get this year drop is 72, which is larger than 64. So we can mostly guess. No proof, no, not a fact, right? My only educated guess is that some routers have got a looker rate of 64 bytes. And if it's larger, they drop it because maybe they are applying a layer 4 access control list on the transit traffic, and they don't know, so they drop. Okay, anyway, that's a fact, right? So routing headers. As expected, routing header type 0, which has been obsoleted, is dropped. About 90% of the traffic is dropped, and 81 is going through. Interestingly enough, 4, segment routing. Segment routing is used only in a limited domain. And if you look about all the draft and the RFC, they say traffic having the code point 4 arriving in my domain, if you are using segment routing, you should drop it. So obviously in this case, a couple of providers were using internally segment routing and were dropping packets coming from the outside with it. So it kind of works. And all the rest, 1, 2, 3, and Ron, you'll be pleased that your CRH 5 and 6 are going through as expected, so that's perfect. Atomic fragments, they are heavily dropped, right? 30% of the drop happens there. But normally atomic fragments, there are no more use, right? So that's kind of okay. If you're using normal fragmentation, we see no drop, so which is cool. And like I said, authentication header, that's fine. No next header, that's fine. 100% transmission. Ethernet payload, that's fine as well. So that's the early result. We try using some heuristic to find which AS is doing what. And we were having about 6 or 7 tier 1 in there. So that was important. And no wonder most of the tier 1 do not drop. There's more like some access ISP that drop it. So wait and see on this. More details will be coming because currently the heuristic that we are applying, I mean, I'm not that confident in them. So we are trying to get something much more accurate for dropping. And there are well-known papers from Kaida and others on this. Next slide. We also have an operator survey. So for the operators in the room, you can forward the email. It's in the slide. So click on it. There's a couple of questions. We simply want to know whether you are applying some specific policies based on extension headers. Of course, again, it will be a sampling, so nothing really scientific, but always help. If you know about a VM provider, or you are happy to host a VM running Linux and Python and Scapy on your IPv6 site in Africa, please let me know. Okay? While we are here, I can even pay you a beer or a glass of wine on this. And then the other one is maybe redo something like Jen, Fernando, and Tim did, not only sending traffic between the vantage point, but also sending traffic to Alexa 1000 or some BGP prefix and see what has changed compared to 6 years ago. That's the next step. So stay tuned for Philadelphia. We should have more result there. And as I said, we really need to get more information about the AS. So there are some techniques used by, notably by Qaeda and others to do it, and that's the next step. And the last slide, before going to big queue of questions, which looks like an IPv6 extension of the chain with so many extensions one to the other. That's the GitHub for the code, right? This means master students quality code, right? So, but it works. Okay, I see some questions.
I actually see quite a few questions, but I'm afraid we're going to have to take this to the list.
Are we doing any here, or are we going straight to the list for questions?
Let's go straight to the list.
For the people here, I'm here, right? So.
Yeah, Ron, I think you're next.
Hello. Hello, can you hear me? Okay. Okay. We wanted to outline the procedures for this working group. We had some discussion about what the role of a chair is, when something can proceed, when it can't. So we just wanted to take some of the ambiguity out of it. Next slide. The steps to publication you're all very familiar with. Post an internet draft, that's mandatory. Discuss it on the mailing list, that's mandatory. Present it at a meeting, that's optional. Have a working group call for adoption and a working group last call, both mandatory. Next slide. Posting an internet draft. The file name should be draft, your name, V6OPS, and your topic. Post a message to the V6OPS mailing list inviting review. And the chairs will determine whether the draft is in charter. And our charter can be found at this website. So this is a chair function to determine whether it's in charter. Next slide. Okay, now the next thing you're going to want is some time on the agenda to present your draft. What are the pre-requirements? Well, you must have a new or updated in-charter draft, and you must have at least some discussion on the mailing list. Meeting time allocation rules. Drafts that have been adopted by the working group get time first, individual submissions next. Chairs may deny a request for meeting time if the pre-requirements haven't been satisfied, if there's no time on the agenda, or if the draft has previously failed a call for adoption. Now, this last bullet is important. If you're asking for a call for adoption, you probably want to have some review on the mailing list early, clean up some of the issues that came up, because then you must get your request. Chairs may not deny a request for any other reason. That's to say, I can't say, you've requested agenda time, you've met all the pre-requirements. I don't like the draft, so I'm not going to give you time on the agenda. No, I can't do that as a chair. Next slide. Calls for adoption. Again, pre-requirements are the same. A new or updated in-charter draft, some mailing list discussion. Chairs may deny a request if the pre-requirements haven't been satisfied or if the draft has previously failed to call for adoption. Chairs must not deny a request for any other reason. When the chairs issue a call for adoption, they also begin to track issues with the data tracker. They begin to track issues in a transparent way, so we know what's outstanding. Next slide. Now the chairs judge consensus to adopt. If they adopt, if the working group agrees they want to address the problem, if they agree the approach is reasonable, and if all blocking issues in the tracker have been addressed. To be adopted, you only need to be good enough to be a starting point. You don't need to be good enough to publish. And in the discussion on a call for adoption, we'd appreciate it if you posted technical issues only. +1 support or opposition doesn't count. Those kind of messages, won't make the way into the tracker and won't have much effect. Chairs must recuse themselves from consensus calls on drafts that they have co-authored. So if I co-author a draft in this working group, I must recuse myself from the consensus call. Next slide. Working group last call, all of the issues in the tracker must be addressed. The chairs may deny a request if the pre-requirements haven't been satisfied, and chairs must not deny a request for a last call for any other reason. Next slide.
Last slide.
That was the last slide. Okay, so this should be just, rules for fair play. I don't think it'd be very controversial, but I see folks at the microphone. The Torlis.
So, Ron and Fred, this is Xipeng Xiu from Huawei, and I would like to make a suggestion. First of all, I want to say that, I fully support this procedure. But this procedure seems to me, on every slide, it starts with a draft. So I think that this is a good procedure for managing the draft submitted to the working group. I agree with that. But I think that in our charter, there's also a statement saying that, V6OPS want to solicit input from the operators and users. And if we insist that, if you want to provide input, you must have a draft, then I think that this can be limiting to us. So here I want to propose that does it make sense for the meeting presentation? I'm only talking about the meeting presentation. For example, in the future, can we always have 2 sessions in each IETF? So we add another session, and then we invite, some other, for example, either operators or users, or even IPv6 deniers, to talk about why, what kind of challenge they see. Because, for example, recently, there's this big debate in Nano, right, about the use or not use of 240/4. A lot of people in the mailing lists are saying that, you feel that, IPv6, there are so many challenges. To some extent, that we are kind of like dismissing them. Say that, if you stop this dispute, you spend half the time, patching IPv4 on IPv6 would have been done. But we are not really acknowledging the challenge they see. So I wonder if it makes sense, for example, to add 1 more session in each IETF, because there are a lot of interest on IPv6, there are a lot of challenges. And this way we can bring more input, and kind of like identify the challenges more so that IETF can solve them better. Thank you.
I think that you have a good point here. Because we're an operational group, we're a little different than the rest of the IETF, and maybe it would make sense for us to have some kind of joint session between all of the NOGs and this working group. Would that work for you?
Yes, thank you. Because I think that some of these challenges, for example, various IPv6 councils or IPv6 forums or maybe Nano, they are also talking about it. But my feeling is like V6OPS, we probably have more talent. I think that this may be the the better places than other places. I think that, for example, if people talk about their challenges here, some of us may document their challenges and eventually us publish the draft rather than those guys, because the operator guys, they may not have the time. But if, you know, we let them speak in this IPv6 council, that IPv6 council or NANOC, then maybe the issue will be mixed. And then in the end, nobody kind of like document all these challenges and put it into a single place that people can easily reference. Thanks.
Okay, let's exchange some emails on the list about the logistics of this, you know, whether it would be an interim meeting, what NOGs would be invited, what other organizations, but this is a good idea. Warren.
Thank you. Warren Kamari, Google. So I don't know, I mean, I like this general idea. I don't know if we definitely need a separate session each time. I think what it should be is what many working groups do, where they use the first part of the agenda for adopted work, etc. And then if there's any time left over, we use it for new work. I mean, for some meetings, we might have 2.5-hour sessions and only 15 minutes or 20 minutes of working group business, and it seems silly to have a separate session just for new work if we're not using all the time. But yeah, I mean, to me it seems like a reasonable idea to have some set of the meeting time put aside for, you know, new science project ideas or presentations on other stuff. And V6OPS was doing something kind of similar, where it would do invited presentations from like operators on what they found from deployment or similar. So I think the procedures are good in general, but I think there should also be some time for, you know, discussing new work or floating ideas.
Okay.
Oh, and that was with no hats, clearly.
Actually, I'm kind of envious of the hat. It goes well with the mask.
Very cool. I mean.
Jared.
And the badge.
Yeah.
Don't forget the IETF protocol police badge.
So there's one other thing which is sort of a well-known secret, but not a secret at IETF, which is the IETG meeting, which was yesterday, where the you know, where a number of network operators actually do show up and talk about issues as well. And so it's sort of this interesting thing, because actually a lot of people, even in the IETF leadership and, you know, the IAB and ISG, don't really know what it is. And so it's something where I think there's an opportunity to also leverage that, because, for example, at least one of the presentations that was here today was also there yesterday, but there was opportunity to have a bit more of a conversation dialogue based on the agenda time that was available. So I think that's another opportunity and venue outside of these direct working group activities as well, to go and socialize things.
Thanks. Let's bring discussion of the logistics of this to the mailing list. I think we all agree it's a good idea. The only question is who and how. And with that, I'll give it back to Fred.
Well, so can you hear me? Meet Echo is asking me if I'm talking, and I'm not, so I don't understand.
We can hear you.
Okay. So with that, we're within 2 minutes of the top of the hour. I guess this is going to go to the list in the next week or two. And so thank you very much for your time, everybody.
Take care, all. Oh, wait, Luigi just came to the... Nope, I guess not. Take care, everybody.
Whose adapter is this? Thank you, whoever lent it to me, but I'm going to steal it if you don't come back and take it. I have it upstairs, I just keep forgetting. Thank you, sir. although I like this